Welcome to this new episode of Do It Right, Dynamic Hydronic Balancing. Great to see you again. In today's episode, we delve into the world of dynamic hydronic balancing by comparing how two distinct 6-pore pressure-independent control valves perform within a common application scenario. Together, we will uncover what sets them apart in terms of comfort, controllability, and efficiency. Let's consider the case of an office building with independent temperature management on each floor and in each room. It's a typical setup, one that's designed for flexibility and user comfort. But this flexibility comes at a price. The hydronic system becomes extremely dynamic, constantly adjusting to different demands from different areas at different times of a day. In this kind of environment, maintaining stable flows and reacting quickly to pressure instabilities is essential. That's where the type of valve you choose really matters. Let's compare two solutions, the electronic 6-pore PICV and the mechanical 6-pore PICV. At its core, a 6-pore valve is made up of two 3-pore ball valves mounted on a common axis, one for the supply line, another for the return. This clever design allows a single actuator and valve to manage both heating and cooling. This is exactly how the Siemens 6-pore PICV is engineered: compact, efficient, and precise. Both provide the possibility to manage heating and cooling with a single valve, but when it comes to performance, the mechanical 6-pore PICV has a clear edge in several key areas. Let's start with flow presetting. Why does that matter? Well, in many applications, both mechanical and electronic 6-pore PICVs need to limit their operational stroke to match the system maximum flow. However, this presetting reduces the available rotational range for control, leading to lower precision when modulating the flow, especially at partial loads. Unlike the 6-pore PICV, our mechanical version comes into two dedicated DN15 variants, each tailored to a specific flow range. And this design allows for a wider stroke range to be utilized. Consequently, this results in enhanced modulation, more stable operation, and accurate flow control. Now, let's turn to flow control. In both solutions, the flow is managed by rotating ball valves based on control signals from the BMS. But there is a key difference in how much control you actually get. The electronic 6-pore PICV operates between a 30 degrees stroke range per operational mode. And if the maximum flow has been limited during the presetting, the usable stroke becomes even smaller, further reducing the valve's capability to modulate flow with precision. In contrast, the Siemens mechanical 6-pore PICV offers a wider operational stroke, up to 40 degrees, compared to the 30 degrees stroke typically found in electronic versions. Why does that matter? Because the valve is not just opening or closing, it needs to navigate 3 functional positions, one for heating, one for cooling, and one for fully closed position. With a wider stroke, the valve can distribute the heating and cooling control over a larger rotational angle, allowing for more precise modulation between each mode. And this leads to smoother flow transitions, better part load performance, and ultimately, more stable room comfort. Now, let's talk about balancing, the key function of a PICV. In the electronic 6-pore PICV, balancing is done by rotating the actuator and valve, just like in the presetting and flow control. This rotation compensates for under or overflows caused by pressure instabilities in the hydraulic system. However, this mechanical movement takes time, typically between 60 and 90 seconds, depending on the magnitude of the pressure instabilities. During that delay, the terminal unit may be receiving too much or too little flow. Comfort is not achieved, and the system ends up using more energy. Our mechanical 6-port PICV, on the other hand, is equipped with a built-in mechanical pressure regulator that reacts almost instantly in less than 5 seconds. It doesn't wait for commands or rely on actuator rotation. This quick, autonomous adjustment helps the system maintain a constant flow, stable comfort levels, and significantly reduces energy waste due to prolonged imbalance. So, to summarize, the Siemens mechanical 6-port PICV brings clear advantages in dynamic systems: better sizing flexibility, greater control resolution, and faster reaction to pressure instabilities. This is especially important in modern buildings where heating and cooling have to be independently controlled, and where efficiency and comfort are non-negotiable. That's where Siemens delivers with the technology that makes it possible. Thanks for joining this episode of Do It Right, Dynamic Hydronic Balancing. I'm Alejandro González Pozo, and I look forward to see you next time.